In this lecture, we're going to talk about chemical properties and how they differ from physical properties and the types of physical properties, extensive versus intensive. Let's begin. Let's start with chemical properties. Since we're in chemistry, this is often the one that we deal with. So chemical properties. Chemical properties are those properties by which we test some matter, that's anything that takes up space, to see if it will change. Now we say change. Will its properties change? Will it go from yellow to blue? Will it go from no smell to a smell? Okay, so the changes are very, very important. So when we talk about chemical properties, we're talking about the ability of this piece of matter, this substance maybe, and we'll talk more about what that substance means, has the ability to change into something else or lacks the ability to change. For instance, hydrogen, okay, as we're going to learn, is H2 gas. What this really is a hydrogen molecule, we'll do that red, bonded to another hydrogen molecule. Now, it likes to react to oxygen. Now, we had one H atom, and we have another H atom. So these are two H atoms bonded. Of course, now with oxygen, we have different atoms bonded. So I'm just going to draw them with just different sizes. This one of these, of course, is an oxygen atom. Okay, the smallest pieces of matter. But now, what's happening is that when this reacts, it likes to make H2O, very classic reaction, which means two of the oxygens react with, two of the hydrogens, I'm sorry, react with one of the oxygens. And they make a new substance. Now, how do I know they make something brand new? Well, hydrogen gas is colorless, but it is a gas at room temperature, and it will explode. It is explosive. Oxygen is not explosive by itself, but it helps other things burn. So the presence of it can cause explosive, as in this case, but it's also colorless, and it's a gas at room temperature. At room temperature, H2O liquid is in a liquid phase. We just made something called water. Now you may say, well, how do I know I made something new? Well, two gases come together. You might say, well, first of all, Mr. Grodsky, how could two H's, what happened to the other O? Okay, well, really what happens here is you need two of these H molecules, particles, and one of these, and what would happen is, okay, you would have those two H's hooking up with one oxygen. All right, so that's how it really works. You see, this H and this H is over here, and these two H's are over here. And if you notice, this oxygen is over here, and this oxygen is over here. So what just happened to make this a chemical change is that the atoms were rearranging themselves. They broke apart here, and they rearranged into a different chemical formula. But that chemical formula really means the ratio of these particles. So when I say chemical change, will it make something brand new? And chemically, we know it makes something brand new because it makes a new chemical formula. We started with hydrogen. That's a gas that bonds to itself. So H2 means two H atoms. We started with oxygen. It's another gas that loves to bond with itself. And there it is. When they react, they pull apart from each other and rearrange to make H2O, a brand new chemical formula. Guess what, people? A brand new, okay, particle. This is one O and one O bonded together. This is one O and two H's. And when that happens, all their properties change. Color. The phase can be from a liquid. It could be able to conduct electricity. In this case, water has a lower melting point. a different smell, okay? So all the properties change when you make a new substance. And what it really means is that you're changing how the atoms bond into some brand new form. And we always see it in a chemical reaction, okay? For instance, sodium is a metal that's explosive, plus chlorine gas, that's a non-metal we'll learn about, that is toxic. Together with two of these, you make something called sodium chloride, which is table salt. And we all know table salt is not explosive as pure sodium is, okay? And it's not toxic like chlorine gas. It has a brand new set of properties because we made something new. This was just one sodium, and this is what? Two chlorines bonded together. They pull apart, okay? In fact, there's two sodiums there. Remember that two there? They pull apart, and they reform something brand new, which in this case, we'll just make it simplified, a sodium with a chlorine. And they make a brand new pairing. And when you make a brand new pairing, it's identified by a brand new chemical formula. All right? And therefore, we made a brand new set of properties. Now, there are some things that don't change. We're going to learn neon, okay, as we'll learn, is a noble gas, and it resists changes or chemical changes, so it sticks around. So its chemical property is the inability to change and react and pull apart and jump with different atoms. It doesn't like to be with other atoms, so it doesn't make anything new. So its chemical property is that it's inert. It doesn't react, okay? Now, what is physical then? Well, a physical change, okay, is one where there is no new matter, we'll use the word substance eventually, being made. If there isn't something new being made, then the properties of that matter, that substance, that compound, that molecule stays the same. So the properties do not change. The properties stay constant. So we're not talking about pulling atoms together and rearranging them. We're just using these properties and identifying something from them without making the change. Case in point, if I take something, let's take something like a solid. Let's take gold, okay? So we take Au, and it's in the solid phase. You know, I can add heat, and it can become Au in the liquid phase. In fact, gold has a pretty low melting point compared to other metals. But the idea is look at the chemical formula. Au is the symbol for gold, Au, okay? And that chemical formula is not changing, okay? It's an A and a U. It's actually for aurum, which is the color of the sun, okay? Rising sunset or rising sunrise, and it's a Latin word. But the point being is that it's just a chemical symbol. That's the chemical formula for gold. It's not changing. We're changing it from a solid to a liquid, but we're not changing what makes it. So this is an atom of gold, and then it becomes a what? It's still an atom of gold. So that we didn't change anything. So the properties of gold still stay the same. Now in the solid phase, the gold packs itself more tightly, and in the liquid phase, because the gold has what? More energy, it's more freer. That's the difference, but that's a physical change. Going from the same chemical formula to the same chemical formula is a physical. So therefore, things we're going to call phase changes, a solid going to a liquid, going to a gas, as I like to say, gas, okay, because gases have tremendous energy. These are all physical changes because we're not changing the chemical formula. Lo and behold, look at water. Water's H2O as ice. With heat, it can become H2O liquid, and with gas or water vapor, gas, H2O G. Are we changing the chemical formula? No. So anytime you talk about any phase change, you'll hear the word melting. You hear the word boiling. Now, melting, of course, is a solid going to a liquid. Boiling is a liquid going to a gas. But what if we go the other way? What if we come back from a gas to a liquid? Well, if you remember, that's condensation. That is a phase change. That's physical. And when we go from a liquid to a solid, we know that's to be freezing. These are all physical changes because guess what? The properties are staying constant. Okay? And that's how we do this. Okay? Now, this is how we do it. Now, physical change. I could take a piece of paper. Oops. And I can cut it up to small little pieces. It's still paper. It's physical change. Chewing is physical. Okay? Identifying a color is physical. Hey, identifying density. When you measure density, which is mass over volume in your first lab, did we change the copper, change the aluminum? We were able to measure density based on evaluating its volume and calculating and measure its mass and doing a simple division calculation. We didn't change the aluminum by measuring. But in a chemical change, if you test for something that's flammable and you burn it, well, it becomes something else. It changes to CO2. So physical changes, there's no change in the chemical makeup, in the chemical formula. All right. Now there's two types of physical changes. All right. One is called intensive, and one is called extensive. Intensive, and this is the way I always remembered it, I for identification. What does that mean? I can identify things based on intensive physical properties. That's right. Couldn't you identify the aluminum in your lab by measuring the what? Density. I can identify what something is based on its density. It's physical because I'm not changing the substance to test for it. It's intensive because I can use it to identify. Extensive is based on the size of the sample. You do not identify things based on extensive properties. Case in point, I want you to know which of the following is gold. I have something that's 10 grams and I have something that's 100 grams. Just by telling you the mass alone, can you identify what the substance is? Of course not. You can have 10 grams of anything, 100 grams of anything. So the size of the sample is extensive. What if I've got 20 milliliters of something? Can you identify something based on just the volume in this case? And the answer is no. So mass, how much space something, how much of something you have, is extensive. Volume, that's how much space something takes up, is also based on the size of the sample. These are extensive. You cannot identify. What if I say color? Where would color fall in? Well, if I gave you aluminum and I gave you gold, don't they have different colors? So I can use to what? Identify them. I for what? Intensive. So when you break this down, we have chemical properties, and chemical properties are based on making new properties. Physical is about keeping the properties. You're not changing the chemical, so you're keeping the properties. And there's two types. There's the intensive, which is used for identifying things based on their properties. And then you have extensive, which is based on the size of the sample. So let's go now to your homework, your worksheet. Let's do a few together. So here is our homework worksheet, and we're going to skip this first part. And we're going to go on to the second page where we look at properties. Okay, so here are our words. We have the extensive physical, we have intensive physical, and we have chemical. Notice there's no such thing as extensive chemical or intensive. All right, so I want you to try to take these properties and try to label them as physical or chemical first. And if they're physical, which type of physical? The one that's used for identification, intensive, or the one based on the size of the sample? So as we go, let's figure this out. So number one, color. Do you think color is based on the size of the sample? Can something be more yellow because it's bigger? Oh, yellow is yellow based if it's small or large, so it's not based on the size of the sample. Is color something that's chemical? Well, we know flames can give off colors, and those certainly that could be a case, but generally speaking, when you're observing the color of a compound, are you changing it? And the answer is no. By you looking at a color and deciding what the color is, it's certainly, for the most part, physical. And could you identify things based on color? Well, I can. If things are moldy on my sandwich, I know that it's a wrong color. So you can identify samples of metals. In fact, the metals in your lab, the first lab, had different colors. So clearly, it's intensive physical. Why is it physical? Because by identifying the color, we're not making any new changes to the substance. We're not changing the chemical form, we're not breaking any bonds. Number two, combustibility is a word that describes how well something will burn. Okay, it's a measure of how well it would burn. Now, when something burns, for instance, in class, on the first day, I took methane, which is CH3. It's a carbon and hydrogen. I reacted it with oxygen, and guess what I made? I made CO2, carbon dioxide, and water. This is a chemical reaction. What's happening? The carbon, which was once with the H's, hooked up with the oxygen, and the oxygen went with the H's. They rearranged to make brand new substances, brand new pieces of matter that have brand new what? Properties. The properties change in burning. Okay? So combustibility is chemical. The ability to change. Some things do not burn very well, but that's still a chemical property, the ability or not. Number three, hardness. What do you think hardness would be? When I measure the hardness, like a diamond, the girl's best friend is a diamond, right? Well, you can test to see if your boyfriend or your fiance gave you a diamond, but see if it cuts glass. A lot of things look like diamonds but don't have the hardness of diamonds. Cubic zirconium can look exactly like a diamond but have no hardness. Any case, when you do a hardness test, do you destroy the diamond? The answer is no. So we're not changing the chemical formula, and we're not changing any new properties, so it's physical. The question is, can you identify something based on the hardness? Absolutely you can. Okay? Cubic zirconium is a guy's best friend, right? All right, any case, so this is a intensive physical property. Definitely we can use to identify whether I got the big rock and whether that was a diamond or a fake. Intensive physical, because when you do a hardness test, you are not pulling atoms together and changing them. You might crush it a little bit if it's a cubic zirconium, but you're not changing the atoms. Crushing something into smaller pieces is not pulling atoms away. Okay, number four, density. When you guys did the density, we talked about this already, but density is mass over volume. To put something on a scale and to calculate its volume using a ruler, are you changing the atoms involved? Are you creating something new? And the answer, of course, is no. So it's physical. The question is, what kind of physical? Well, we can identify things based on their density. That's what Lab 1 was about. So this is another intensive physical property. How about mass? I'm not talking about Sunday mass. I'm talking about how heavy something is. What kind of property is that? When I find someone's mass by putting it on a scale, do I know what it is? Can I identify something based on how heavy it is? Of course it's not. But when you put it on a scale, are you changing its chemical properties? Are you changing the atoms involved? Are you making something new? Hope not, because every time we got on a scale, we become something different. We might burn ourselves, okay? So mass is a physical property, but you can't use it to identify things. You can't identify gold by how heavy it is alone. All right, so it is an extensive. Extensive is based on the size of the sample. So it's an extensive physical because when you mass out something, you do not change the chemical formula. Okay, melting point. This is the temperature at which the substance turns to a solid to a liquid. Every single substance or piece of matter has a unique temperature at which it'll turn into a liquid. Well, if it's a unique temperature, if I melt it, I know what temperature it melts at. So the point being, as the bell rings, okay, is that melting point, okay, I can use to identify something. We know that water boils at 100 degrees Celsius. So its boiling point is unique. It also freezes or melts at 0 degrees Celsius. So the melting point of water is unique, so I can identify something based on that uniqueness. And by the way, freezing, melting, does that change the chemical formula? Does H2O get broken apart when it melts and freezes or becomes a gas? The answer is no. Just separate its distance. So this is something I can use to identify because every substance has its unique intensive properties, and of course it's physical because when you do so you do not change the chemical formula. Okay, ductility is a measure of how well some metals can be pulled into wires. So it's the ability to be drawn into a wire. Not all metals can be made into a wire, so think about that for ductility. Volume is how much space something takes. Failure to react with other substances, what kind of property would that be? Odor, something smelling, is that a chemical or physical? Maybe some of these could be both. How about weight? Very similar to mass. Malleability is the ability of a metal to be hammered, malleable, into thin sheets, or to be, let's just say hammered, into thin sheets. Not all metals are malleable. Okay? Malleability is really the idea that a metal, once heated, can be made into any shape possible and won't break. Okay? It's very similar to ductility. Tendency to corrode. Corrode means, think about metals or your bike, they rust. So tendency to rust. Is rust a new substance? Think about those. And of course, these are all examples. I want you to do the same thing. I want you to try to name the property listed above. So I'll give you a hint. Milliliters is a unit of volume. So you would put volume here. Okay. So try this. The rest, I have the key posted. Good luck.